Hello, everyone. Welcome to the course of world history. I am your host, Mr. Samuelson, and today we are looking at the scientific revolution in a series of revolution-based episodes in our unit, The Age of Revolution. Check that out. All right, the scientific revolution is going to kick us off. Our essential question here is, how did the Renaissance lead to a revolution in the sciences? So we're going to start it with the Renaissance as that kickoff place, and then carry it through this whole explosion of scientific knowledge in Europe. So let's look at the Renaissance. Now, during the Renaissance, Europeans gained that renewed interest in the works of ancient Greek and Roman thinkers. They were looking at all these old texts, which they had gotten from Arabic and Byzantine sources, and were refamiliarizing themselves with kind of their own history. And in this process, they were re-examining the works of their own historians, philosophers, etc., and discovering some problems with some of their work and starting to question the past in a way that they hadn't before. Part of the reason for this new questioning was because of advancements in science, particularly math. But what got many Europeans started on this line of thinking came from advances in navigation technologies and learning more about the world around them, which got them questioning what they had been taught in the past and learning how math can help them to answer certain difficult questions. And if math can help them get a better view of the world through navigation technologies, what other issues might math help them to solve or resolve? What questions could they have answered through the science of math? One of the areas that they looked at was astronomy, and we're going to dwell on astronomy for a little while because this really kicks off the European imagination here. In the 100s AD, this fellow down here, Ptolemy, was this Greek philosopher who created a model of the universe, and it was a geocentric model, putting Earth in the middle and everything else rotating around the Earth. Now, 1453 comes around early in the Renaissance, and this model is rejected. Nicholas Copernicus is using math to try to calculate a more realistic picture of the universe itself, and he creates the heliocentric model with the Earth and all the other planets rotating around the sun, a new way of looking at the universe. Now, a little while later, Galileo Galilei is going to go even further. He's going to build upon Copernicus's observations and use large telescopes for the first time to not just look at the planets and track their movements, but to see their surface and to realize that those planets are, in fact, Earth-like bodies moving through space. These observations confirm that the Earth was one of many planets. So we're not just glowing heavenly bodies, but spheres of rock and gas, just like Earth. Now, Isaac Newton, I'm a huge fan of Isaac Newton. I wish we could spend weeks on Isaac Newton, but he gets one slide. Isaac Newton is the boss. He is, when it comes to science, he is the pinnacle of science, and is the most impactful scientist of this age. And we'll only talk about him a little bit for astronomy, but his mind is so amazing. He's trying to learn more about planets. He's trying to figure out why planets move the way that they move. And the math at the time can't help him solve that question. So he invents calculus. He invents new math so that he can better make new astronomical discoveries, which he then does. He takes those discoveries even further and uses calculus to discover the universal law of gravitation. So he started out with, why are the planets moving the way they are? And he winds up discovering why everything moves the way it does. He discovers this universal law of gravitation, explaining the movements of all objects in the galaxy until Einstein comes along and ruins it because very small particles don't follow the same rules. But still very impressive for Newton. You demand. All right, medicine and chemistry. How much further does this go? Well, in medicine, scientists come up with this novel idea of studying human bodies to learn more about human bodies. We're going to stop dissecting animals to learn about humans. Instead, we're going to dissect humans to look at human bodies and learn about humans. Yeah. Up until this point, religious authorities had really frowned upon that. But now the medical needs and the medical advancements of science are really showing the benefits of knowing, what human organs do. Chemistry goes even further. It's during this period that these different elements start to get names and categorizing, not just names, they had names. But we started to be able to figure out the system that later becomes a periodic table, and where elements belong in relation to each other on that chemical level. All right, women in the sciences. Women's get to go into the sciences. No, they don't. Not really. Yeah, the Renaissance is not all that kind to women. Women were still largely kept out of the sciences, but many of them insisted on contributing anyway because women are like that. Yeah, break the rules, change the world, do it. A couple of those women in the sciences early on. We have Margaret Cavendish. She is writing about the limitations of humans to alter natural laws. A lot of male writers at the time were talking about how the purpose of science is to overcome nature. And she's saying, whoa, 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 we are a part of nature. You can't overcome yourselves. We're not overcoming nature. We are existing within a natural world and a part of that natural world. There is no overcoming. Maria Winkelmann was a German astronomer, worked alongside her husband for a number of years, and helped to discover the existence of a new comet. Now, after the passing of her husband, she took her work, that was her work, and tried to get admitted into the German Academy of the Sciences and to work with others and learn with others, and was rejected because she was a woman and history's just not kind to women. So glad things have gotten better. We still have a ways to go. Let's move on. All right, Descartes and rationalism. So this is kind of the science of the mind, but we're going to build upon it a little bit later. This is a realization that is built upon the idea that if the Earth is not the center of the universe, which religion, philosophy, etc., had always taught us, like we're the center of everything. Well, if we're not the center of anything, and in fact, we're this small little piece that might even be insignificant on a galactic scale, then what is really truly important? What is going on here? We're not the center of the universe. Well, René Descartes tries to figure out then what is. And he actually separates the self from a physical and mental being, and saying that what's really important about us are our thoughts, not our physical existence. The idea, I think, therefore I am. It is my thoughts that really truly matter. And using this and building upon this idea, his philosophy expanded it to say that if we want to know what is really true in our society, we don't listen to religious authorities. We don't listen to really any authority. What we do is we observe the world and use our rational thoughts to make sense of it. If you want to know what's true, pay attention, learn, study, and think. And you can learn the truth. And that is the idea of Descartes. Now, Francis Bacon is another guy who's going to kind of build upon this. Francis Bacon, though, interestingly, is not a scientist himself, although we kind of lump him in here, because he creates one of the most important things to ever be created for scientists, and that is the scientific method. He's saying, we shouldn't rely on just philosophy. Descartes has taught us, I think, therefore I am. Use rational thought and observation to figure out the truths about the world. Okay, how can we build upon that? We need to use rational thought and observation. In science, we need a scientific method. The scientific method is a systematic procedure for collecting and analyzing evidence, observations. Okay, this scientific method requires scientists to use fact-based observations, not, what we learned in our religious classes, not what people told us was true. We have to observe it, and we develop hypotheses about how we can generalize these observations that can be tested through experimentation. Okay, if this is true, then we think this will be true. We can test it in this way. The results of these experimentations can then be used can be generalized and can be widely applied. Okay, so scientific method, you have a question, you develop a hypothesis, you experiment, you look at your data, you analyze that data, and you report on it whether your hypothesis was correct. Scientific method, boom, scientific revolution. We use this to this day to learn about the world that we live in. It's awesome. That was this lesson. I hope you learned something, and I'll see you next time. Farewell.